As a way of introduction, one of the first problems we run into when we talk about automation is, what is automation? How does it affect you? How are you going to implement it? And one of the philosophical solutions we come up with is that automation is an assistant. He's there to guide you, to help you through the process, take out the cumbersome details that you would normally have to do in a manual operational process. And obviously, it brings up accuracy. So today, we're going to talk about the restrictions, the requirements to build an automation system to run Hadoop OS upgrades, what it encompasses, and also how to get through an upgrade process, what's involved, and actually the automation assembly, how we assembled the process. First of all, we are a very small operational group. We have 20 Hadoop research and production clusters, and in fact, like we heard this morning, all clusters are in production mode, 42,000 servers, and when you split it up over 2 shifts, 12 hours long, we have 4 engineers per shift, or 10,000 servers per engineer. And person on call gets 42,000 servers for that 12-hour shift. So we have a mix of hardware, storage, and configurations. We have 1 to 40 months of server age we have to deal with. We have mixed environments ranging from 4 to 12 drives, and this accounts for 50% of our break-fix issues. We heard earlier that we are running 0.2 exabytes, and we're almost what we would call big operation. However, we need help. So this is where we're trying to fit automation. We are a small operations team with a large number of nodes that has immediate opportunity to upgrade the OS on thousands of nodes in a limited time to the required OS and security levels, and repeat. The process never ends. It's an actual journey. You begin down a road of automation, and you actually never can turn away from it. It always changes due to OS upgrades, changes in security policies, and so forth. So it's only possible, though, if we apply Hadoop's ability to tolerate node failures and to upgrade multiple clusters simultaneously. And the tools and implementation of how we did this is what we're going to talk about today, too. So what can we upgrade? In effect, a Hadoop cluster has multiple components. There's critical servers, and there's the data node or task tracker servers. The data nodes are upgradable. The rest are not as far as this process is concerned. The others require job downtime. However, the whole process is almost like an octopus. Its tentacles reach out to gateways, to name nodes 1, name nodes 2, to job trackers, and to all the data nodes, and to admin servers, to boost servers, to DHCP servers. The list goes on and on. It's all a combination of all these servers and all these environments put together that make this whole process work. So the requirements given to us was we have to upgrade the OS, and as it turns out, we just went through a large phase, and we have to redo it over again with the next release. Apply it to thousands of nodes. We have to upgrade multiple clusters concurrently to get the speed out. We have 20 plus clusters, so thus you can do X number per day times the number of clusters you would want to run at any single time based on your tolerance in your environment. A maximum requirement is, because we're running production, we're running live, there's no service downtimes accepted to us. So any event that would happen during the process would be considered an event error and would have to have remediation. We would like also minimal admin oversight, and with tight controls, the process needs to be self-governing. You don't want to wake up in the middle of the night and check on your automation. The automation should, if it runs into troubles, automatically shut down, pause, or just not do anything for a while, which is what we actually try to achieve here. And it also requires you do extensive production validations. You want to validate that the node you do remove is valid, that it can actually boot, come back in, and it's also can be loaded to the name node and the job tracker without any problems. So we went into this interesting dilemma. Should we automate? Automation requires a significant amount of investment in time and effort. It is a long-term process, and again, the process never really ends. It's ongoing throughout your span of your operations. The process itself does span weeks. However, manual efforts require multiple teams. If we did a major knife switch one weekend, suddenly do an upgrade over thousands of nodes, we would have significant number of people that are required to be on site and on hand to be able to deal with all the issues that could come from that. And we have also believed that our senior staff is better used to doing other project-oriented work besides doing the little details about manual operations. And most of all, skip to the rest, is that accuracy is important. When you remove a node, you have to know that that node has a good chance of rebooting, comes back in, and the name node can actually accept it, and the job tracker will accept it, and you can continue on. If you don't, you increase your dead pool, and a large dead pool in the Hadoop environment is a negative because we run our clusters to maximum. 90+% is not unusual. So what's the customer impact when we do a live upgrade on all these data nodes is that their slot usage or the jobs slots gets reduced. And those slots, when we reduce them, take a node out, those temps have to be rescheduled to other nodes. The HDFS storage has to be below 85%. It's only a problem if it is above. It's a customer impact. Decommissioning time is interesting. It can range based on the number of blocks you have allocated per data node from either from a few minutes to a few hours, sometimes 20 hours, and the time and traffic involved in that process. And when you do take nodes out of service, you have rebalanced it or moved the loads to different nodes. However, your name node is going to be unbalanced, and then you have to go back and balance the system again. So you might have pauses while you go through that process. So again, work concurrently with production, no cluster interruptions, multi-generation hardware issues. The older the hardware, the less likely it will reboot and be upgraded, though that's pretty a low percentage. Our clusters are fully utilized, thus the processes become slower because it takes longer to decommission nodes. The network security changes or network services all impact automation. Any minor change to DNS, to all the LDAP services, and any other services in the environment will impact your automation process. And your maintenance windows. We do frequent upgrades of Hadoop, and these windows have to be tolerated throughout the process, and the process must continue to operate after the systems come back up. Functional requirements. When we want to start this process, we want to do a one-click. Click, and the whole grid gets upgraded 4 or 6 weeks later. So we need to have start, stop, standstill operations, be able to control the process in case we feel it's getting out of hand. We need to set a pace. How fast do you want to? What we've been doing successfully is cloaking. And that way, we're acting like dead nodes, nodes that are just failing out naturally. So we go through the process of randomly select nodes, we drop them out, decommission them, and then upgrade them and return them, and quietly. In fact, Sanjay didn't know that for 6 months we were upgrading all the grids. It's a quiet operation. Any events would be noticed quite dramatically. So we consider that a major success factor. We need to track the node conditions, completed operations, and create intelligent state workflows. And this is the key to our automation process, the workflows. So we come to a final decision. Should we do a cluster outage, a night switch, 1 weekend, maybe it goes longer? We will have to expect boot failures from our servers, potential for missing blocks. For any of you who have tried to track down missing blocks on nodes that didn't return, it's a daunting task. The name node isn't really suited for finding out which node actually contains those blocks. We need to extend outage windows if it goes too long. We've actually had to do this live in our production environments also. Or do we do a live cluster upgrade? Because Hadoop tolerates these changes, these minor systems going out in and out. We can, based on peak capacity and storage usage of the particular grid in question, be able to move nodes in and out quietly without anyone knowing. Obviously, we have change orders and so forth. And the fact that Hadoop makes it easy to decommission and reactivate nodes is a major plus. So live or outage obviously went live. So the OS upgrade process is 3 major steps. And so first of all, we have to find out the state of the node. As you know, nodes will come and go as they please. The name node has an idea what the state of the node is, and so that's called the live list. The dead list is the node list where the name node thinks that these nodes are no longer suitable for service. Same applies to the job tracker, and they will get blacklisted if there's problems on that list. So you look at the name node help page, you have to scrape it You have to scrape the job tracker status pages, and you run SNMP to check the OS rev levels. And the nice thing currently, oddly enough, is that the files to move nodes in and out is simply one little simple flat file. On the name node and on the job tracker, DFS or MR map read include or excludes. We either add the node to the file or remove the node from the file to bring it back in. It's quite a simple process, and we actually taken major advantage of that. So here's the live node. We checked the name node is on the live list. We qualified the OS. We went to the bootable process, looked at all of our admin servers, and they said everything was set to go. Our MAC addresses matched. That's another thing. If you have multiple interfaces, you have to make sure that the interface you're going to boot on matches the interface that you're in your DHCP server, and that your console is actually working. It's best to do it that way. And then once you qualify the node, you add it to your exclude lists on both systems. You wait for both systems to finish. And at the time that the name node finishes, he'll add the node to the dead list and remove it from the live list. And during the decommissioning process, if you look at the live list, it'll say decommissioning in progress, and it'll tell you how much time it's been going on. So the process never does anything without a dead list confirmation. It allows us to make sure that the nodes come and go only when they are exclusively dead, and they're dead on both systems, the name node and job tracker. So we update our boot environment and cause the system to reboot and to re-image itself. At this point, we should have an upgraded OS. And of course, time has gone by, roughly, depending on how much storage you're going to reallocate, is roughly from 5 minutes to an hour. So at this point, we verify the OS has been upgraded. We validate the file systems. And then the dependencies, we install Hadoop release, and we activate that release. And we start and verify the data node and task trackers. And at this point, the node returns back to the grid, and it's live, and no hands have actually touched in these processes in the middle. So how did we assemble this project? One of our requirements when going into this process is that we need to use off-the-shelf environments. We have the ability to write shell code, but it can look and work very complicated. It can look very complicated, and the syntax to write really good error tracking shell code is quite extensive. So we decided to go with code generation, be able to enter keywords and have it output methods and classes, i.e. more methods inside of shell bash codes that are executable and standalone. We need a web interface that gives us security. People have to log in. They have to have access to it to be able to manage all the jobs, scheduling and launch jobs, be able to have like a cron-like entry, and to manage the audit log secured process. Obviously, auditors are interested when you move material in and out of these grids. So all this has to be SOX compliance. We need to build a database to track the nodes. We need to secure the connections to these nodes, and we need to use workflows and swim lanes. So basically, what we put together is a Hudson plus Perl and Bash and MySQL, put them together in SSH to the nodes, and we have a complete environment. Notice there's nothing really magical that isn't already involved and already included on a Linux environment. So this is a typical example of, this is not a typical example, this is the majority of the workflow. They are modularized components. We actually create an outline of what we want to do as far as the logical aspects of the operation, which is either scheduling, looking for nodes, looking for the process, is a node upgradable, and forcing the upgrade, recoring, and bringing the node back into the service, and starting up the data node task trackers. So we have 4 layers, which is Hudson, which is we chose as our primary interface. It gives us everything we ever want, and be able to also to clone jobs. So if I can get one cluster running, I can actually clone that job inside of Hudson and apply it to the next cluster. And then I can have a whole range. Obviously, I can fill it up to as many clusters as we have. And again, that's 20 plus clusters. We need to have secured remote connections via SSH. However, there's a little catch to this. Not all keys are all available on all servers. In fact, your home directory isn't mounted, so you have to play clever games, but you have to log in as yourself. You have to have admin access. This is all for SOX compliance. They want to know who did this, when, and where. So that's also included in the process. And then we need to reduce complexity. What happens is that you go through this process and the logic gets a little bit complicated, or it changes over time. You need to be able to pick modules up, move them from A module to B module, or share them across modules. And you need to improve the maintenance. When an activity occurs, we need to be able to go quickly, change it, change the validations, and change the verifications built into it, and be able to do it and bring it back into production quite quickly. So we ended up choosing, as I said, Hudson as our job interfaces, and this is the primary why. It launches modules in parallel. And this example here, it's a little harder to read, but we've got 3 concurrent processes running. It allows for parameters, so I can select a job, manually enter a job, and get it started as a change in the environment, or I can have Hudson just run it as default parameters. Access at Yahoo is secured, and it manages RO logs, which is really quite cool. I've actually gone through audits with this kind of logging system. It's easy to create projects. Like I said before, you can clone existing jobs. You create an environment for each cluster. It's actually hierarchical. You can attach multiple environments together, and you can build your clusters. You can clone your clusters quite easily just by changing a few items. And it's team shareable. Obviously, anyone can bring up a Hudson console. So what's our conclusion? We began in production mode 1/11/11. It's a good date. And we actually started our deployment, or our validation deployment, on December 1st, 2010. So far, we upgraded over 5,000 upgrades in 150 days, or roughly 33 nodes per day. And again, the pace is not really significant. The idea is that you're doing an upgrade always as time allows. In fact, I am doing right now node upgrades on 2 clusters. You can do a planned upgrade. The planned upgrade, what we plan for is for a 4 to 6 week window to do an entire grid. Our grids range from 500 to 4,000 nodes. So it's also based on the density of how much storage you actually have on the node, because as you move things in and out, as I described before, you're going to add things and take things off the dead list. That dead list is a maximum cap you want to put on that. So runaway trains are not accepted. You can't, if you make a typo error, you don't want it to go any further than a limited amount. So that caps the amount of time that it takes for a full OS upgrades. And the engineering time, I usually spend 1 to 2 hours per day monitoring the process. Nodes that are left in the cracks as they go from live to dead to upgrade, there's holes in the crevices in those transitions, and you have to go and find these nodes and do break-fix operations against them. So our results are we deployed a self-managed operation for automation. It continually runs also for break-fix, so as nodes come back, they're repaired, they come back in the environment, this process actually senses it and actually returns it to the grid, hands off. It requires minimum staff. It's a one-click launch via Hudson Jobs. It's a grid service impact has been transparent, except the one time I made a typo. And the upgrade times varies according to your size, to your grid, and so forth. But if you just do the root file system, you can quickly get it in, re-image the root, and bring it back into service within 20 minutes to 30 minutes. It's pretty fast. The reason why we do a root image and not just do a YUM upgrade, though that is an option I have also, is that you have the problem with YUM going back too far. Again, like I said, there's nodes out there that are 3 to 4 years old, and they're out of date so much that YUM can't do an upgrade. This process ensures that the root file system is zap clean. It's very small, 8 gigs. We reload it with the new OS with all the patches on it, and there's no question at that point. We also have the process of re-imaging all your file systems. This is really important as you go to Linux 6. You go from ext3 format to ext4 format. You're going to have to reformat all your disks. So the amount of time and the amount of storage that you're going to offline is going to be based on how much you actually use. A 12-drive system is significantly longer than a 4-drive system, and we have a mix of both. So the decom is either 15 minutes to 5 hours. The kickstart process is 1 to 3 hours based on number of drives, and if your kickstart process or your imaging process runs, your file system builds in parallel or not. And to activate the node is actually quite quick, 15 minutes. So our conclusion. Hadoop has made this all possible. I've worked in a lot of environments, and it wasn't possible to do live OS upgrades. It allows us to shut down parts of the cluster to do maintenance, to do configuration management changes, to remove or add nodes as will, and that's what we're doing. It allows jobs to attempt failovers, and it allows us easy management of nodes and so forth. There's things it doesn't like, that is keeping state changes and so forth and retaining node states, but those are future improvements that we saw this morning also. So my final thought on this matter is that you start small, you get it working on one node. This is a one node concept, by the way, and you think big. You're going to upgrade thousands of thousands in the future. Even though you might have a small environment now, in the future you could have a very large environment. So any questions? Hudson is a continuous integration environment. It's overly used for this process. The question was, you didn't understand what Hudson was. It's redefined for this process. Let's put it that way. We do not use it to build code on it. We simply use it to launch jobs. Okay.
What kind of validation or data integrity checks do you have as you go through this upgrade process?
Validation of data. That's a good question. There's a problem with unbalancing a grid. If you're plowing through a grid pretty quickly, 100 nodes a day or so forth, you're going to create an unbalanced effort. So you have a choice, or we actually had the choice of how do you want to do this? You want to wipe all file systems, bring a node in that's zeroed so you don't have to revalidate the data, or you can let the data node itself communicate with the name node and do the validation and whether these blocks need to be deleted or not. We chose just to do the root, bring back a full wherever the file systems are, and let Hadoop processes remove the excess blocks that are no longer valid. And it leaves the balancing of the grid back to the name node. And that way we don't have holes. And as you go through the live list, you'll see it looks like a bar chart of various ranges. And this way we can have an even range. Otherwise, we would be forced to start the balancer activity, and the balancer activity is also limited to the amount of bandwidth you had set for that grid, and thus you could take 2 weeks to rebalance your environment. And we also, in addition to all this stuff, we also validate everything else on the node that we need to validate as far as is it suitable to return to the grid. We have a lot of minor validations we put in place.
On a given cluster, do you have to finish the upgrade cycle before starting the next one?
It would be nice to be able to do a full upgrade without having to restart over again. However, we have mixed OS levels. Just because we have a one cluster doesn't mean that all nodes in that one cluster have the same OS rev. So the answer is, you will, if a new release just comes out, which it did recently, what do? Do you stop the upgrade process and then use the new release and then go forward with that? You probably do. It's really up to you. It's up to your validations of whether you validated that the new OS is going to be played together with the older OSs. Most cases it does. Not every case is going to happen. So I would say we will stop the process, or we'll just finish what we have. The process is the same no matter what. It's a matter of tolerance for the management of the site, whether the grid is in a production or in a research, and whether it can tolerate a mix of OS environments. Most cases it can. It's running Java, and pretty much that seals the deal for that. Thank you. Oh, you have a question.
I have a question. So if I understand correctly, you use this to do operating system upgrades on the grids, right?
Exactly.
Have you ever thought about doing that for upgrading the Hadoop release?
Yes, and we haven't done it. You bring up an interesting point. You figure that if you can do this piece of it, you can do a lot of other pieces of it. And those are all true. Yeah. And so the next phase would be to sit down and go through all the workflows or all the logical aspects of doing a rolling or shutting down and doing a full upgrade of a Hadoop grid. It would be trivial. And now that we did the OSs and dealt with all the reboot issues, yes, that's highly suitable for this process.
Cool, that would be awesome.
How about at least a JDK upgrade?
Yes, of course. The process we use to bring back the nodes into service actually validates 3 levels: the comps, the Hadoop releases, and the JDK releases. And that process only needs to be triggered in this case. So the only problem is that you end up doing the same thing all over again anyway. The fact that you're upgrading JDK means you still have to shut down the data node. If you shut down the data node, there's no guarantee you're going to bring it back up again. Thus, you're into this catch-22. You're doing a full outage. And since you're doing a full outage, you got to do a decommissioning. Since you're doing decommissioning, you might as well just redo the whole OS upgrade all over again. It doesn't add that many minutes. Again, it's offline. It's your assistant. It isn't a replacement for full-time people. So in that case, you'd say just turn it on and just do a full release of the next release, whatever coming out.
So OS upgrade works because OS doesn't affect much of, the OS version doesn't affect much of how Hadoop works.
It does. There's all kinds of parameters in the OS that you would have to tune, that are tuned specifically to run Hadoop environments. So it does have that impact, but one grid can have multiple rev levels of the OS. And so, am I answering your question?
I think so.
Okay. Yes.
Sorry, I have a question. So in the light of the previous answer or whatever, the person who just was standing here.
The timer, yes.
Yes, exactly. About the upgrading Hadoop, you were saying that it would be a nice process to upgrade like full Hadoop release of the Hadoop. The question is really, because you were also talking about data node and task tracker. As far as I know, today you cannot upgrade task tracker without upgrading job tracker because they have to be build compatible.
Right.
Yes.
Right.
So this one is really only for OS level upgrade,
right.
not
And
really for Hadoop.
That's really important to note that this is not Hadoop upgrade, because when we take a node out, we actually bring back the node to the exact same level it went out on. Because our upgrade process, our release process is that we simply shut down the node and we do a flash release across all nodes. So we want to make sure that that process never changes at this point in time. And that the only thing we're doing is dropping out the node as if it died, and then bringing it back up and keeping the same release on it. And that is really important. This is not a change in Hadoop releases. This is only a change to maintain all these 42,000 machines that we have sitting out there. Thank you. Oh, yeah. Time for one more? Okay. I can barely hear you. Yes.
And you said that's because of going up, YUM updating older releases can be a hassle.
Right.
What are some other reasons that you like prefer the Kickstart?
Why would you do a Kickstart versus a YUM upgrade? You know, if you're going to do an outage, a full outage, you would probably do a YUM upgrade. But you also have to assume that the OS is at a consistent level, that YUM has been tested in all the OSs you have in that grid. The Kickstart is clean. If you have 3-year-old systems, some of our systems were up for 800 days. And it's like your level of trust on that node is really low at this point. You don't even know this thing's going to reboot. And you don't know what kind of problems you're going to uncover if you go through the reboot process. So it's safe that you want to go through the OS upgrade, find out what happens to the grid or to the node. If it dies, you want to get it fixed. You don't want to have it sitting there, you know, just a few days later and all of a sudden die on you. And you want to do this in a controlled operation. That way you know what the status of the node is, what caused it to fail. You can actually scan the logs and so forth. And then you can perform a break-fix operation in a manner that you would find acceptable. Okay, thank you.